Okay. You all ready? So I'm going to start in this corner right here, okay, on your circle. So this is the unit circle, and we call it the unit circle because the radius of the circle is 1. So the R of the circle all the way around would be 1. So here, yesterday we talked about the sine of theta was the opposite over, I know, somebody messed with my thing. All right, the opposite over the hypotenuse. So if this is my theta, the opposite would be y, and the hypotenuse would be my r. And I just said for the unit circle that the radius was 1, so the sine of theta is going to be y. We also talked about the cosine of theta yesterday, and that was the adjacent over the hypotenuse, which would be x over r, and the r is 1, so it would just be x. It's okay. It's okay. So in the top right, got it? Okay. In the top right, the tangent of theta is going to equal the opposite over the adjacent, which is going to be y over x. So when we do all of our graphing on a coordinate plane, we have coordinate points, and we have an x and a y, correct? When we plot points, we do the x and the y points. Yes. Okay, so the reason I made you put your phone away, and the reason that I'm doing this beautiful artwork that we're doing, is we are going to do this until spring break. Spring break. And I'm doing this so you can start by knowing and understanding this. If you all are just sitting there thinking about what's for dinner tonight, I might as well just sit down and we call it a day. Okay? When we plot, I plot points with an x and a y. On the circle, my x now is the cosine of theta, and my y is the sine of theta. So my coordinate points are going to be cosine of theta and sine of theta. And just like x comes before y in the alphabet, so the cosine, the c comes before the s. So you can remember how to do that alphabetically, okay? So the next thing I want to talk about is, so this is quadrant 1 or quadrant 2. This is quadrant 1. This is quadrant 3, and this is quadrant 4. And so we talked about that yesterday. We talked about the quadrants make a C. So if I look at the first quadrant, my x values are positive, and my y value is positive. So I'm going to have a positive and a positive. In the second quadrant, what happens with my x's? They're negative, but the y is still positive. In the third quadrant, what's true? Negative and negative, right? The x and y are both negative. And in the fourth quadrant, the x is positive and the y is negative. So the next thing I want to do is I want to look at the quadrantals. I want to look at the quadrantals. So that's the 0, the 90, the 180, and the 270. So at 0, I have 1 and 0. The radius is 1, and I'm not up and down any y values. So what happens at the 90? Do I have any x's? No x, but a 1 for the y. And so at the 180, what's true? Do I have any y's? No. But what's true about the x this time? So it's negative 1 and 0. And at the 270, what's true? 0 and negative 1. Okay, so take your little triangles and just flip it down, flip them both down so we can only see the top one. Yeah. What? Just flip them down so you can just see quadrant 1 and 2. So eventually we're going to have to memorize all this, right? We're going to memorize it all. And so to start with, I want to just look at some patterns, okay? I just want to look at some patterns. So first of all, if I start at 90, do you see how that's pi over 2? Okay. So then the 90 degrees is cut into 3 parts. So if you look, if I start at pi over 2, then I go 3, 4, and 6. Correct? Does everybody see that on the denominator? So look at the second quadrant. Look at the denominator. If I start at 2, what's the next denominator? 3, 4, and 6. So now I have to go to the 90, which is on bottom, and that's 270. Because there's my 2. And if I count up, just look at the denominators. 3, 4, and 6. 3, 4, and 6. So if you start at the 2, going up both sides, it's 3, 4, and 6, all the way around on the denominator. Okay? So now, if you look at the first quadrant, these are all pi's. Pi over 2, pi over 3, pi over 4, and pi over 6. Okay? Go to the second quadrant. The denominator is 3, but the top is 2. The denominator is 4, but the top is 3. The denominator is 6, but the top is 5. So those are all 1 less. So pi's and then 1 less. If you go to the third quadrant, what is true about the numerator? It's 1 more. So the first one is all 1s. The second one is all 1 less. The third one is 1 more. And the fourth one is twice the denominator minus 1. It's just the way the pattern is. It's twice the denominator minus 1. So 2 times 6 minus 1 is 11. 2 times 4 is 8. Minus 1 is 7. 2 times 3 is 6. Minus 1 is 5. So that 1, 1 less, 1 more, twice the bottom minus 1. Okay? So that's all the way around. So that's our radians. Okay. So now we're going to do the fun part. Okay. So now I need the coordinates. Oops. I need the coordinates all the way around. Just slammed on the floor. Sorry. I bet that was loud. Okay. Okay, so I want the coordinates all the way around. So here we go. So turn everything down except for the green one. This is my 30-degree triangle. And so the coordinate points, I want the x and the y value. So the x value is the square root of 3 over 2, and the y value is a half. So fill that in. Huh? I know. So flip up the pink one. So now we're at 45. The x value is the square root of 2 over 2. The y value is the square root of 2 over 2.
Are you always going to have these numbers in? Or you're going to find them sometimes?
Well, you're going to memorize them, so it's going to be okay. So the 60 is 1/2 is the x, and the square root of 3 over 2. Okay? So turn your thing back down, and I just want to look at the 60 now. So do you see that the values are the square root of 3 over 2 and a half? So yesterday we talked about reference angles, and it wasn't clear why I was trying to teach you what a reference angle is. If you go to the second quadrant and put your green one up, what's the x value for the 30 degrees? It's just negative square root of 3 over 2 and a half. Because the x in the second quadrant is negative and the y is positive. So what do you think? Down here, this is the reference angle right here. This one is still the square root of 3 over 2 and a half, but in the third quadrant, they're both negative. And in the fourth quadrant, it's still the square root of 3 over 2 and a half, except this time the y is negative. Does that make sense? So we found the 45, and I know the 45, they're both the square root of 2 over 2. So you can fill the middle one all the way around. They're both the square root of 2 over 2. Just make the right ones negative and positive. So in the second quadrant, I know that the x is negative. So it's negative square root of 2 over 2 and a positive y. If I use that reference angle and I flip it down, it's still the square root of 2 over the square root of 2, but they're both negative this time. And if I went to the 45 in the fourth quadrant, this time the x is positive, the y is negative. So a positive square root of 2 and a negative square root of 2 over 2. Does that make sense? So the last one is my 60-degree angle, and I know every time it's 1/2 and the square root of 3 over 2. So if I go to this one, in the second, the x is negative. So a negative 1/2, a positive square root of 3 over 2. What's it going to be in the third quadrant? Both are negative. We said both are negative. The x and the y are negative. So negative 1/2, negative square root of 3 over 2. And what's true about the fourth? The x is positive and the y is negative. So if I ask you, what is the sine of 60 degrees? What is the sine of 60 degrees? So here's my 60 in the first quadrant, and is sine x or y? Y, so it's the square root of 3 over 2. What if I wanted to know then what is what's the cosine? It's a half. If I want to know what the secant is, the secant is the inverse of the sine, so it's 2. Now, the tangent, we said, is the sine over the cosine. Do I have a sine and a cosine so I could find the tangent? Okay? So it's a pattern all the way around. So, eventually you are going to memorize this. And the sooner you do it, the better. And what I would do for sure is make sure you know the first quadrant. Because if you know the first quadrant, can't we do all the others? Yes. So I would make sure you learn that. And we're going to give you some tricks tomorrow. But y'all, there's nothing I can do. You have to memorize this. Spring break. We are doing this until spring break. It's going to be fun. It's super fun, as a matter of fact. Look, it started with beautiful, colorful